Alright, here's my video assignment for week 3. So, first of all, I got the schematic diagram with all my givens and my schematics. So, for state 1, state 2, and state 3. So, here are all the things. So, I assumed a few things as well. I assumed that it was an ideal gas for simplification purposes. I googled what a piston cylinder device was and found that it's a closed system, so that means the mass would stay constant. And also, as it's stated in the instructions, there's a constant pressure between states 1 and 2, and a constant volume between states 2 and 3, so that's another assumption. In analysis, so I decided that I would use the combined gas equation to find, in the piston cylinder, to find what's missing, to find the saturation pressure and saturation temperature, to be able to determine what state it is. What type of, what phase, whatever that is, and then I would use, that to find the missing temperature in state 2 and the missing pressure in state 3, find that, to then find what state it is in, using this equation here. And you can use this equation assuming that it is an ideal gas, and that mass is constant, so, yeah. Alright. So, I used the equation here. I substituted it in, converted the Celsius to Kelvin, crossed it out, rearranged, got this value, Kelvin, and put in Celsius. It's a very large value, a bit too large, whatever. And then did it to find the pressure. Did the same thing, except to find pressure. Rearranged, found this pressure, which is in megapascals. So then I rewrote everything, and then I wrote down my givens for each of them. I found out the saturation pressure for state 1 using the tables. Using this table here, A12, was it A13? It was A13, I believe, actually. At A11, actually. So it was this one, using this value here, which was 185. Did that here, found that the original pressure is greater, so it should be a subcooled liquid. So that's the state of the first one. And the second one, using this value, I was able to find, using a given of 200 kPa, which was right here, 200, got a saturation pressure of negative 10.09, to give you a T-sat there. Here, this temperature here is greater, so that means it would be a superheated vapor. And then for the last one, I would use a temperature of 80 degrees, using this table right here again. I believe 80 degrees, which would give a saturation pressure of 2,635.3. Put that there, kPa. At this time, it's less, which is the reverse of that, which should also give a superheated vapor. So then, now that I found the states, here's my TV diagram. So over here would be T1, which would be a subcooled liquid. I kind of skipped this, whoops. And then both of these would be superheated vapors on this side, somewhere here. There's a critical point, whatever that is. All right. And then the next thing is to find H1, H2, and H3. So how did I do that? So this is a subcooled liquid, but there is no subcooled table. So I googled it, and it apparently decided to tell me to use just a saturated table. So I did that just for negative 12, right here, using this table, and it gave me an HF, a saturated liquid of 35.9, which I went with as my H1. So H2 and H3, there is a bit of a problem. It's specifically my value for T2. I made a mistake somewhere, not sure how, but so it's too big, so the value's not there on this table. It's not possible, so I had to use a little calculator on the internet to see if I could get it, but it gave an undefined value because it's not possible at such a high temperature. So that's not what it is, but yeah, it gave undefined, so I just found the maximum possible, which would have been around 713. So it would have been greater than that for my value that I found. For state 3, I did the same thing. I put in this online fluid calculator, and it gave me a value of 326.56 kilojoules per kilogram. So those are my values for H1, H2, and H3. Thank you.